Hi, thanks for joining us. Let's dig a little bit deeper into bridge design using some analysis and then passing our bridge design off to Revit for structural detailing. First off, let's take a look at some of the options we have for analyzing and understanding material quantities in our InfWorks 360 bridge. Notice here that we can select a bridge and right-click to get the quantities, but then if we change the bridge type to steel plate, the quantities will recalculate in addition to the pier spacing recalculating as well. Now, notice that my piers reset back to a standard style. So if you wanted to update that, make sure you update the piers back to your custom pier style. You also have the option to perform a line girder analysis when we are using a concrete bridge. Within the analysis panel of the bridge tools, select line girder analysis and then fill in the project information. This will help keep track of any analysis you run as well as separate revisions one from another. So you can put in a company name, the username such as mine, initials, that sort of thing, and then simply press the Start Analysis button. Now, line girder analysis is a pretty complex operation, so it'll take some time. You'll come back to your model later, select the bridge, and then open up this panel to see the results. They're not going to come up right away. The next step in looking at our bridge, at least from a geometry standpoint, is something we probably should have done a little bit earlier in the process, and that's to actually check for clearance. Now, in this case, I'm going to turn the road and deck back on, but I'm also going to select my bridge, and in this case, I'm going to turn on the clearance envelope over in the design panel. Now, by adjusting the start and end offsets, you can see I'm moving that purple box, essentially where am I looking for clearance under my bridge? And then I can adjust the height requirement. Now, this could be for an at-grade intersection. This could be for a mast height if you're going over a recreational lake. But once you have an envelope, if you then select the bridge and right-click, you'll see an option to update vertical profile, and notice how it bumps the bottom of my bridge just a little bit higher to give me the clearance that I need. With the clearance in place now, I'm going to pass this bridge over to Revit, where my structural engineer can do things like rebar and stirrup setup. Now, in my case, you'll see this warning where I'm using an unsupported coordinate system because I had left InfWorks 360 working in lat and long. Open up the model properties and then select an appropriate local coordinate system for your model. Click OK, and now you can repeat that process. Again, select the bridge, right-click, send to Revit. Now, the send to Revit process will take a few moments. So once you have it processing, it might be a good time to get a cup of coffee. In my case, we're going to fast forward just a little bit here. Remember, we're turning all of the bridge elements into actual solids. So we're going to create some Revit families, do those sorts of things, and it will automatically open up Autodesk Revit when you're done. Now, once the model of the bridge is completed and brought into Revit, to make sure you actually get what you want, you'll want to go up to the View tab and then select 3D View, Default 3D View, and you'll see your bridge available for view, rotation, all those sorts of fun things right in the Revit canvas. Thanks for watching this video. To learn more, join the InfWorks 360 community by visiting the website on your screen. There you'll see forums, the idea station for sharing your ideas, and Infra Tips, where you can learn more ways to make InfWorks 360 a more powerful part of your infrastructure workflow. Thanks again.